Hi guys, today we're going to be talking about experimental design and some of the key questions, concepts, and ideas you need to know about when designing an experiment for the AP Statistics course. I'm going to give you as little information as possible so that you won't have to memorize a lot for the AP exam. These are the principles of experimental design. Now I'm going to tell you, these actually show up fairly often on the AP exam, so you want to memorize them. And all these are saying, for every experiment, you need to have these three things in them. You need to have a control group or some set of standard conditions to compare the effect of your treatment or your application. You need to repeat that experiment multiple times in order for it to be valid, or do it on many subjects so you don't have to repeat it multiple times because that may be expensive to do. And you need to randomize. Remember how we said bias is bad? Remember how your science teacher and every other teacher in the entire world says bias is bad? Well, we randomize, which means we assign treatments randomly to subjects in order to reduce bias on our part. So remember that. You want to have a control group, some sort of repetition, and randomization in your experiment when you design it. And we'll get to designing things later. Anyways, so you need to know the difference between an observational study and an experiment. In an experiment, you are actively imposing something. I cannot stress that enough. You are actively making a difference in the existence of your subjects. An observational study, yeah, you may be dividing your observers into groups. You may be qualifying them on some characteristic or labeling them, but because you are physically not changing how they're existing or going about their lives, it's not an experiment. You're only observing. So know the difference between an observational study and an experiment. Experimental unit, this is the smallest thing that your treatment is applied to. So if I was doing an experiment with seeing which fertilizer causes trees to grow the best, right? Well, my experimental unit would be the tree because that is what my treatment is being applied to. The fertilizer is being given to the trees. A factor is the explanatory variable. And that's an explanatory variable is the thing that changes. The thing that you are actively changing in your experiment. I gotta get a pen. The level is the degree of change. So if, let's say going back to the fertilizer in trees example, if I had fertilizer that was 10% potassium, and then you had another was 20% potassium, and so on, those degrees of potassium would be different levels of the same factor, or the same thing I'm changing. Response variable, what you're measuring. Simple as that. Now, treatment is a specific experimental condition applied to the unit. So this is a treatment. A treatment is just going to be a factor. See, I need to buy a Wacom tablet. And a level. A specific factor with a specific level is going to be a treatment. So let's do a practice example. A consumer group wants to test cake pans to see which works best. It will test aluminum, glass, and plastic pans in both gas and electric ovens. So these are some of the questions you're going to see on an AP exam. They're going to ask you to identify these sometimes. So let's try this. Experimental units. So what are the units? What is physically being tested or shaped or changed in this experiment? Well, we were trying to see what bakes evenly. So what's being baked here? Cake batter, right? So that's going to be experimental unit because that's what's being acted upon. Factors. Ask yourself, what are we changing? Well, we're not changing the cake batter. We're acting on the cake batter, but we're not changing up the types of cake batter. But we have types of pans and types of ovens. And for each factor, for each thing that changes, how are they changing? Well, for the pan, we have aluminum, glass, and plastic. And for the oven, we have both gas and electric. So those are your factors, levels for your factors. Response variable, what are we measuring? And we say right here, how evenly the cake bakes. That's what we're measuring. And the number of treatments. Well, to find the number of treatments, you can just multiply your factor. You can just find the number of specific treatments for your factors. So for the type of pan, we have 3, and for the type of oven, we have 2. But remember, for each pan has to go in each type of oven, so we multiply 3 times 2, and we get 6, because those are the total possible combinations of factors and levels.